When the price of a common product abruptly spikes or plummets, human reactions are wildly unpredictable. People scatter, they hoard, they ignore the change entirely, or they abandon the product altogether. Think about the difference between table salt and a sports car. If the price of salt goes up by 10% tomorrow, your buying habits barely shift. You still need salt. But if a Porsche goes up by 10%, thousands of potential buyers will walk away. Intuition tells us these two goods belong in different categories, but policymakers, economists, and major corporations cannot run massive economies on intuition. They require mathematical proof to understand exactly how consumers will react. Elasticity is the mathematical tool that sorts these messy, unpredictable human reactions into a definitive quantitative taxonomy. The foundational metric for this system is the price elasticity of demand, represented by the letter E. You calculate it by taking the percentage change in the quantity of a product demanded and dividing it by the percentage change in that product's price. This single formula establishes three primary categories. If the resulting number is greater than 1, demand is elastic, highly sensitive to a price change. If the number is less than 1, demand is inelastic. And if it equals exactly 1, it has unitary elasticity, representing a 1-to-1 ratio between price and demand. Because prices move up and down, economists need precision tools to average out the differences. They use arc elasticity to find the middle ground between two separate price points. For ultimate precision at a single price, economists use point elasticity. This graph in Figure 3.3 shows how to measure this geometrically directly on the curve. By taking the distances from point C to map the specific line segments NM and ON, you can calculate the exact elasticity at that specific spot on the line. Measuring this baseline coefficient is the fundamental first step in sorting any goods market behavior. We can push this taxonomy further by changing the key variable from the price of the good to consumers' income, introducing income elasticity of demand. This chart, Table 3.4, shows how this categorizes what we buy. Any positive number classifies an item as a normal good, but the math creates a strict subdivision. When the coefficient is in 0 and 1, the item is a necessity. When that number exceeds 1, the formula classifies the item as a luxury. Now look at the bottom rows, where the coefficient turns negative at high income levels. These are inferior goods. At income levels above $24,000, champagne becomes an inferior good for this individual as they shift their spending toward better alternatives. By tracking income elasticity, we can mathematically prove whether a society views a specific product as essential for survival or a marker of wealth. We can change the variable one final time to map out different products. By testing how the demand for one item reacts to the price change of another, we find the cross-elasticity of demand. Look at this calculation based on the data in Table 3.5a, testing the cross-elasticity between tea and coffee. It yields a positive 0.5. If the resulting coefficient is positive, the two goods are substitutes. If the price of coffee goes up, consumers swap it out and buy more tea. Contrast that with a negative coefficient, which classifies the goods as complements. This calculation for tea and lemons results in negative 0.125, proving they are consumed together. When the price of lemons spikes, people buy fewer lemons, and consequently, they buy less tea. This formula acts as an invisible web, mapping out the interconnected relationships of every product on a supermarket shelf. This taxonomic system applies to producers as well as consumers through the price elasticity of supply. Figure 3-6 charts this with an upward sloping supply curve. This metric classifies how rapidly and flexibly producers can alter their manufacturing output when market prices shift. A producer with an elastic supply can ramp up production quickly to meet a price boom. Both sides of the market, buyers and sellers, are bound by the exact same mathematical laws of responsiveness. All of this data leads to a high-stakes business dilemma. If a company lowers the price of its product, will total revenue go up or down? The answer depends on total expenditures, the price of the good multiplied by the quantity sold. Table 3-3 and Figure 3-5 show how elasticity determines these expenditures. If your product is classified as elastic, dropping your price is effective. Consumers are so responsive that the surge in sales will cover the price cut, causing total consumer expenditure to rise. But if your product is inelastic, dropping the price is catastrophic. Consumers are not sensitive enough to the price change to offset the discount, and your total revenue will actually fall. Elasticity is the definitive language businesses and economists use to categorize market responsiveness, map ecosystems, and predict financial outcomes.